everyone has downloaded the set of the files required for the running of this program. So they have provided a library called CS231n, which has the solver and many different testers implemented using numpy for neural network. So we will be implementing a fully connected neural network for which we will require to define forward function, a backward function, and activation functions for each layer. So let's open a new file and make a class for this for a fully connected neural network. So we will be creating this file within the your assignment folder, which should contain the CS231n folder, which has the some of the files which we'll be using, like the solver and the updater, the default updater rule. First thing we do is import. Create a class.
Sanat, can you zoom a bit?
Yeah.
A little bit more if you can.
Is that good?
Yeah.
So the arguments we'll be passing is hidden dim, which is a list containing the size of each hidden layer. Input dim, which will be equal to 3 cross.
Is there a semicolon in the class first line? Class, right? One.
Yeah, I think
Yeah, there should be a semicolon.
Semicolon.
No, colon.
yeah, colon. Yes.
The input size is 3 into 32 into 32 because each image is a colored image, which is 32 by 32 image, and it has 3 channels. Then we define number of classes, which is by default 10, and dropout, which we are not using. We have to give these parameters because the other functions which are defined within the library will look for these values even if you have not defined it. This is the red is the regularization.
Does it drop out or drop out?
Drop out.
Drop out.
Check the
Out.
spelling here. And normalization equals, not plus. So we don't use the dropout, right?
Yeah,
Oh, we don't use the normalization.
yeah.
So I think it's a little bit more prettier if you use the dropout none, normalization none.
Okay. Okay.
You are meaning that I dropout is 1. It means
Is it
that we use the
100%?
word data, right? Like we can
Yeah,
put 0.5 to 1, right?
Yeah.
Okay, that makes
So-
sense. Yeah.
Defines the scale by which we need to multiply the weights. By default, it is e power minus 2.
Why dropout is 1?
You don't drop out anything. Like dropout gives the percentage of.
But that is the keep probability if you don't drop out anything. Dropout means like dropout probability. Is it? I'm wrong or?
Yeah, you're right. But we have not implemented the part where the dropout is being calculated. So if you just give 1.
Oh no,
So
no.
but the scale is 0 to 1. So if it is 1, we are dropping out everything. It is not keep probability. Keep probability is one where we are keeping
I
everything.
understand what you're saying, but we have not actually implemented the dropout.
Maybe we can. It's
This is
better
the-
if we just change the name,
To
even
now-
though we do not implement it.
Okay.
So Pascal is just complaining that the name is not
Yeah.
We will not implement the dropout, right?
Yeah.
So I think it's a fair argument.
Yeah. So the D type for by default is float 32, but we use float 64.
Please add in as import numpy as MP,
As in, yeah.
because you
Yeah.
use the MP. Yeah.
Nice.
Okay, dot regularization. Now we are taking in the and storing it as the class variable, taking the values in. Okay, this variable will hold the weights and the biases. We are using a normal distribution for defining the weights, so we will be taking a variance of which is given by the weighted scale.
Why is that normal layers equals to 1 plus something? Why is that 1 coming
Yeah,
there?
the number of hidden layers, here when you give the number of hidden layers, you'll be giving, like suppose 6 layers you want to implement, you'll be passing the size of the
Hidden layers.
5 layers, but
Okay.
in total there'll be 6 layers. So that will be a list of like the size of each hidden layer, the how many nodes are there in each hidden layer. So if you take the num of the list, that plus and you have to add 1 to it to get the total number of layers that you want to implement.
Oh. So that one is for output layer? Or?
Yeah, output.
Okay.
So the mean is going to be 0 for this distribution with the variance equal to the weighted scale. And the number of dimensions will be input. The biases will be 0 initially.
Can you make the slightly smaller so that I can see the makes clear. Okay. So what is this input dim doing? Input dimension parameter doing?
Input dimension will initially hold the size of the input for the first layer, and for when you're calculating for the next layer, it will hold the size of the previous dimension, previous layer.
Where input dimension is used in your source code?
It is used for like we are going to pass the input dimension directly to the class. I mean, it is a preset. The input dimension will give the dimension of the.
No, I mean,
It's used here.
Oh, it's passed as a parameter in the function.
It's used here.
okay,
So we have to create the weights for each layer,
okay.
and to get the size of each layer for creating the weights, we
I
use the
see,
input
I
thing.
see. Now I got the idea.
Yeah.
Okay.
This loop ensures that all the input parameters are of the same data type. Now we start defining the forward function.
So it says in the first line, it does not have a object is not defined. So in the class fully connected net object, is it like a capital or
It's not capital, it's just,
just the object?
yeah,
I think this is just a generic
yeah.
class property.
Yeah.
But I never define any object kind of thing when I define class.
You are using capital one. So
Okay, so this is not get compiled. Given obj is not
Normally you don't need to
mandatory.
pass anything.
Yeah, because when you're doing the init, you'll be passing using the parameters that you need to.
everybody do not have any problem with this so far without new definition. Can you run the code without error?
No, if you remove object, then it's fine.
Yeah, I think we should remove the object.
Okay.
Fine.
Okay, the affine forward function has takes the inputs, the weights and the bias. So now the challenge is the input is image, so it is n dimensions, that is number of images with the 3 into 32 into 32. We need to bring that down to a vectorized form where there is only one row, one vector representing each image. So we are going to reshape the input.
That should be equal to, right? After NINPD.
This is a new printf. I thought it is a new printf statement in that video.
What is the NIMPT?
So NIMPT will give you the number of inputs. So
Number of inputs.
Yeah.
Okay.
So X has first dimension as the number of images,
Mhm.
and but it has in each image has 3 into 2, 32 into 32. Every forward layer consists of will provide a cache which stores the previous or like X, W and V, which will be used by the backward function.
So everybody familiar with what is affine function? No? So affine function, what is affine function, Sanas?
An affine function, if you do any kind of translation or rotation, it still remains the
Mhm.
same.
Yeah, so it's a linear algebra term, but simply speaking, affine function is something like this. When you have a matrix, it's Ix plus B. This is the affine function in two-dimensional, and this can be vector, right? Then A becomes a matrix, so it's a Wx plus B, which is simply speaking a single neural layer, right? So this is what is happening here, and is everybody clear with why we return cache? Paul, do you know why return? So who else know why we return cache to? Nobody? Okay, let's go continue.
Yeah, I think now when we implement the backward function. So here you see when the backward function requires the cache. So we'll be calculating the partial derivatives with respect to the input, the weights and the bias, for which we require the values of the input weights and the bias. So we
So I think we should use the same name and input T. NIMPT.
Okay.
Yeah.
Could we just put Q in the cache instead of doing this again?
Pardon me?
Couldn't we just put Q in the cache instead of reshaping it again?
Q, when we computed previously, asking if the already
Reshape
in the affine forward function we reduce the dimensions of x and store it in the variable q. So it's asking, can we directly store it in the cache and use it in the backward function instead of
So basically, do we need X for anything else?
So why we need X is
We
it's a
need
very easy
yeah.
when you are using the blackboard. And Sanas, can you derive what is the partial derivative
of
dx, dw, dv?
yeah.
Can you use the blackboard to write the partial derivative for the affine function?
Yeah, so if it's dx with respect to the loss, then it will be
Is this the right or the opposite? Sanas?
sorry,
Is this dx over dl or dl over dx?
L should be numerator and denominator you have to switch.
And
okay.
DL divided by
Yeah.
derivative of loss with respect to
and
X.
don't use the loss yet.
Okay.
We should use the term out.
Out.
Yeah. So
Okay.
d out over dx.
dm over dx
And above write out equals xw plus b.
ah, so if you dx with this with respect to dx will be w.
W plus X.
B is
But W is
Yes,
also
that's
variable,
W.
so you need to chain rule, we need to apply.
so
What?
we dw by no what are you into do.
So W and X both is variable here.
W and x both variable.
But yeah, but we're taking partial with respect to x.
X.
In that case, the others will not be a variable. That's
Yeah.
the reason why it's called partial derivative.
So basically, it should just equal to W.
Yeah.
Yeah.
So basically, we need x because the dx will be of the shape x. So we have to return d out. This will give an output. So the output of this, the dx, is supposed to be the same dimensions as the original x.
Okay.
So to get the original dimensions of x, we need to retain x. That is the
And what is the partial derivative over dw and w and b also?
w.
So everybody clear about this? Who knows? Who don't understand this? Please raise your hand before it's too late. Everybody clear with this? Okay, so please proceed.
Yeah. So we need to take the transpose of the weight because when we are multiplying it with d out, the shape of d out is n cross n. There is number of inputs into the size of the hidden layer. So,
Can you write it there, like according to the size wise?
okay.
So what is the size of X here?
X is n, which is a number of inputs, into 3 to 32 into 32. So it is the 32 by 32 is size of each image, and they have 3 channels. So each image, colored image, has 3 channels, and this entire thing will represent one image. So there are n images.
Okay. And Doug, what is the size of W?
W will be
Just before. What is the size of Q?
the Q will just be n cross this value. If you multiply all this, that will be the size of each row, the vector size.
Yeah. So please use the same notation, Sanas.
Okay.
When you are representing size of X,
Yeah.
you use the comma.
Yeah.
And when you represent the size of the Q, you use the multiplication.
Yeah.
So
Okay.
use the same notation.
Yeah.
And please correct the X.
Yeah.
Yeah, okay. So then,
Here it will be 3 into 32.
okay. And what is the size of W?
W will be D, comma N. This M is given by this.
So let's make the same notation here.
Yeah. So we can write it as 3 into 32. So when we have to take the dot between these two, for it to be compatible, we need to take transpose of Q.
Where we are taking transpose?
I'm writing that line, so I was explaining.
What is D there? D?
D is the size of that input, like the previous hidden dimension.
And do you think if we are doing a find forward, right? Can we do out equals np dot q and w here?
In forward, it is directly compatible, so we can do.
Oh no, is it a size match?
Yeah, in forward, but when we come in backward.
So q size is n m and w is dm. Can we do a dot product of?
No, we can't do this. This q is not the q; it's for the out.
I mean, this right?
Yeah.
Can you do this? If that is the size.
Yeah, but over here, that w will be.
What I mean is.
Yeah, I understood. Because
Yeah.
they are not compatible.
Yeah,
Is
yeah,
it
yeah.
possible?
Is it possible?
No, if it's like this, it shouldn't be possible.
Yeah, that's what I mean.
Yeah,
So,
yeah.
what is it?
Find forward is correct
But
because
these values, what I've written is for the backward function.
Then what about forward?
Q1. For forward, it will be, see, when we do it, it will be matching.
So in the forward, there is x, right?
Yeah,
And x is given by that.
yeah,
And there is a q.
yeah.
What is the dimension of q?
The Q is supposed to be. The dimension of Q is determined by the number of inputs. So N
So
is
q, the dimension of q and q1 is the same.
Yeah. Correct.
And what is the dimension of w in the forward?
In the forward, the dimension of, sorry, we have defined it. It will be input comma hidden. So it will be n cross n. So it's the So the weight here, the size of weight changes, it's not constant. Because for the first layer it will be the input size.
So let's say you are doing the first layer.
Yeah. So
Right.
it will be the input size n into m. Into will be same as the input.
Draw the first layer. Just let's say we are doing a one hidden layer.
Okay.
Input, hidden layer, and output.
Okay.
And what will be the size of W there? Draw it and draw size there.
Okay.
And erase the
Erase the
part.
part.
Yeah.
Input is So it will be n into this size is 3 into 32 into 32.
What? So, what is the size of X in your drawing?
The size of x is the same as the size of the weights.
Write it. What is the size of X?
The size of x is
Given by that, right?
yeah.
And what is the size of W?
The size of w will be input. So input size input dim comma hidden dimension of 1. So the first dimensions we keep that we have. If we say we have size of the first layer, hidden layer is 100.
Look at your source code,
Yeah.
right? Yeah. And if we are doing
So if you see the first, each layer, the
Mhm.
size we are, the number of random numbers we are generating is of the size input comma dims of I. So it depends on the what we set as the size of the.
So if we are using the single layer, what should be the hidden layer?
The hidden layer should be like we can choose the size as
If we are doing single layer, so after single layer is the output.
Okay.
So what should be the hidden layer size here? If we are doing single layer,
It should be equal to the number of inputs cross the vector size, right? Because the first layer.
what is the vector size?
The vector size is the 3 into 32 into 32. So in the first layer we'll have the number of nodes in the first layer will be equal to the number of.
So I'm asking you this, right? This is given by y equals w by x plus b, and there is a we are doing a classifier, right? There is a 10 class. Then what should be the hidden layer for w?
Oh, 10.
10, right? Then what is the size of w here?
So it will be n cross 10.
What is n?
N is the number of inputs.
So write it. What is the number of input here?
You are asking,
You wrote there, so
okay. The number of input will be n. Capital N.
number of input. You said input dimension is 3 multiply 32, right?
Okay. Okay. multiplied by 32, 32, comma 10.
Okay, and compare that what you wrote there.
Oh, this. Yeah.
You see the difference?
Yeah.
So now you see where I was talking.
Yeah, I got. So
Okay.
So if it's one layer, it will be this. So when we take the cross product, we get.
Okay, and let's say we use a hidden layer of 100
Okay.
and use a 2 layer.
And 2 layer. Okay.
Yeah.
So the first weights will be 100. Will be into 100, and the
write it. W1 equals.
W1 equals 3.
And what is the size of W2?
W2 will be this.
Is this right?
No, it should be 100.
It should be 100 into 10.
Yes.
Previous, correct. Do the.
Okay, let's continue. Everybody, do you understand why we multiply? So, do you understand this line? dx equals np dot d out and wt. Do you understand why we are multiplying wt here? We said dx, so partial derivative over x is a w, right? Then why we multiply d out here?
Because that is flowing from the output itself.
Yeah, so what is the d out? D out, how d out is actually, how we can write the d out? So d out here is given as something like this. Of course, there was a loss at the end, so in the middle it might not be like this, but it's a dl over d out, right? And we are having a d out over dx as a w. So we are multiplying this. When we multiply d out and w, it's like a dl
Divided
yeah,
into d out divided by dx.
yeah. So we are basically getting partial derivative over dx, right? So this is why we are multiplying it here. Okay, please continue. So, Sanas, can you explain the partial dB equals np dot sum line? Can you explain it?
Okay, when we are trying to find the partial derivative of the biases with respect, the loss with respect to the biases, we'll end up you'll just get a D out.
So why we are doing a sum and sum?
So the D out is a vector. So if you add all that, that will give the value of the derivative.
So is it dB number or vector?
dB is the number.
Everyone, is it dB number or vector?
Should be vector.
Yongtab, do you know is it dB is a vector or a number?
I think it's scalar, it's a number.
Oh, so did you take a neural net course yet?
No.
Okay, so and Aishwarya, do you think dB is a number or scalar or a vector?
I don't know, I have not been following.
So you didn't take the neural net course yet?
Which course? Sorry?
Neural net?
No.
No. And Paul?
I'm taking it right now, but
Mhm.
I'm a little confused on dB.
So is it dB a vector or scalar? You are not sure.
I'm not sure. B is a constant here.
So and
yeah, I took last semester.
yeah. So is it dB vector or scalar?
I think vector.
Yeah. So those who confused should think this way. When we have this form, right, and you guys can write the size for everything. So let's do the first layer exercise here. So single layer exercise. So what is the size of the y? Y should be. We are doing C part 10, so there are 10 output.
So y 10.
10, right? So it's a vector of size 10. So a little weird, but
1 into 10.
1 into 10. I'm not sure it's a 1 into 10 or
10 comma 1.
10 comma 1. Anyway, it's a size 10 vector. And let's say, what is the size of W? And
That will be
3 into 32 into 32 comma 10.
let's say it's M
that is the last line.
and 10. And what is the size of X here?
So one layer is x is.
Let's say in the our data set there was 1,000 images.
So 1000
1000 comma
1000
3 into 32 into 32.
1,000 comma
3 into 32 into
3 into 32 by 32.
Size of y also
3 into 32.
So, Bhaskar, you first. What did you say?
100 comma 3 into 32 into 32, which is 2 then.
Pardon me?
Sorry, 1000 comma 3 into 32 into 32.
Yeah, so 3 dimension, right?
No, it should be 2 dimensional because
Uh-huh.
second dimension is a one vector, correct?
So
You are converting everything to the vector.
So each channel has a 32 into 32 matrix.
Mhm.
So since it's a color image, there will be 3 such channels. And this entire thing will represent one image.
But Bhaskar is right. So the original image has a single image has a 3, 32 by 32.
Yes.
So you can think this as this number. Actually, it does not look like this. So 32 by 32 is a long vector, and you have a 3 long vector, right? Like this. However, in terms of the neural net, it does not matter if you have this form or layer. So we just concat everything into a single long vector.
Okay.
So that's how we will do. So
So it will be one vector, even though it says 3, that
Yeah,
they
so-
all 3 will be in one vector.
So this is the correct form for x. Then Paul, what are you trying to say?
If the number of inputs is 1000,
Mhm.
then the size of y will change.
Yeah, yeah.
1000.
So it should be 1000 by
10.
10. 10. Right? So we have 1000 by 10 y, and w is this is like this number, and
307.
10 and x. So I'm always confused w x what that w what w that x, but
But you can do WX transpose.
W transpose X.
w transpose x.
Transpose.
Then transpose x. So let's use this form. So w is we call this m. So m comma 10, and x is like
I think
so
that-
we transpose. So w transpose is w transpose is size of what? What's the size of w transpose?
Professor, if we break it into like 1 and 2, so W, if we consider vector is coming 32 into 32 into 3, so each neuron will go for each 10 vector. So W size would be 32 into 32 into 3 comma 10, and we are passing 1000, so W has to go into the 3-dimensional 1000 comma 3 into 32 into 32 comma 10. So for each neuron it can create.
So
It's
we
the
are-
same.
it's
We are multiplying at one time.
Pascal, come here and write down. When there are too many numbers, my mind flowing. So anyway, write somewhere your version, and we'll come back there. But let me write it here. So we have a size for x, which is 1000 by m, and to make this, we cannot go this way. I think we should go this direction. So the W side is m by 10. So so here is the my version. So there can be many different way to write it, but I will write it this way: y equals x w plus b, and the size of x is one. This is the number of images, and m is the vector for single image. And by multiplying x w, you get basically
1000 into 10.
1000 to 10. So we get 10 numbers for each images, right? Now, my question is, what should be the size for b here?
Same.
10.
10,000.
10?
These would be
No, no, no,
1,000.
10,000.
So, Sanas, what should be the size?
10.
10. And Saros,
Yes, to be 10.
10. You did it 4.
10.
10.
Of course.
Sanjay,
This will be the same size of XW.
XW. So it's a 10,000 by 10.
Yeah.
10,000, 10.
10,010. You too. 10,010. So 10,010. So the answer is 10. Right? This number is broadcasting.
Yeah.
So B is a size 10 vector. So that's why dB is also size 10. It should not be, let's say, what should be the size of the D out over dB. So now let's say, what is the dB? dB is basically D out over dB. In the program, we wrote dB, but it's actually D out multiplied by dB. And what we want to get return here is dL over D out multiplied by D out by dB. So, what is the size of this number? Dimension of this number, loss.
Should be again 10.
10?
10 by 1.
Saroj, you said 10. Any other idea? Loss is a loss.
1000 by 10.
1000 by 10. Any ideas? So who think let's do a quick polling? 1000 by 10. Who thinks 1000 by 10? Then 10. How many think should be 10? Sanas, Saroj, Yongta, Paul, Sanjay, and you?
7000.
You, so Paul and remainder, right? And you guys are all wrong.
It should be scalar.
Yeah, it's a scalar.
Yeah.
So you should really take the neural net course again. I can simply say you know nothing about the neural net at all. Those who take the course, don't assume you know the neural net. You don't get the basic idea. You are confusing. You think you know something, but actually you don't know anything. That's your state. So this DL is a single number. And how we get this single number? Let's say for every image, we got 10 number, right? It's like 0.9, minus 1, 0.22. We got 10 number. And we apply softmax, which transforms this into the probability of belonging this. So this 2 is the highest, let's say 2 was transposed to into the something like a 0.3, right? And this means that this neural net think this image is an airplane by the probability of 0.3. And ideally, it should be 1, right? And it thinks it's a 0.3. So simply speaking, you are losing 0.7 as a loss, right? So you got a loss for single image. Basically, you do a log or something, but the basic idea is the amount you are missing is your loss, and you sum all losses for 1000 image. And now you get the single number, right?
So
That is the, pardon me?
So we just add all the loss?
Yeah, add all the loss for all the images. And that's how we get single number. And our goal here is we want to minimize this loss. So we don't care about the single image, we care about how we can improve 1000 image.
So basically you're saying like the values of loss can be like the total sum of the loss can be like 500 or whatever.
Yeah, by number whatever, but we want to lower the loss.
So it's different than the softmax because it has to be between 0 and 1, right?
Yeah. And I said 1000, but there can be easily 1 million or whatever number. So basically we are adding these numbers and we are doing partial derivative over this. Right? So
Can we go through again why the size of the B is 10 instead of 1000 by 10? Because it's a broadcasting, right? It's still like.
So bias is, the definition of bias is, let's say you are implementing simple gender classifier. It offers a female and male, right? And in your data set, let's say there is a 0.70% of the data set is male, 30% is female, right? So you already know about this distribution. So without using any complex features, you can guess, oh, I think it will be probably male by 70%. And we can use bias for this, right? So bias is a bias toward men here. And if you think about now you have a 100 data set about the male, female, male, female, male, female. And by using a single bias of 0.7, you are saying, oh, the probability of being man is like 70%. But what you are saying, like 1000 by 10 is like having bias for every data set. It does not make sense. It is not purpose of the bias. You are basically overfitting, right? So bias is a single number. So that's
Usually we update bias after each training.
Yeah,
We don't
we
create
update
bias
weights
for
and
each data.
Yeah, weights and biases are updated. And here the dB is not dB out by, it's basically the dl by dB actually. The
yeah, you are right. So anyway, so dB is dl by dB, which is dl over dB. So this cancels out. So at the end of the day, it's dl by dB. And what should be the size of the dB?
dB is the number of neuron last layer.
Yeah,
So number of neurons last layer and others.
it should also be single number.
Single number.
Single number.
Size of dB. I'm asking you. Size of dB. So what is the dimension of this expression?
It depends on the number of nodes change.
It was 10.
10?
With 10.
10? 10 Pascal?
It should be 10.
Yeah, it should be 10. So
There is 10.
yeah. So dB is size 10.
It's with respect to each of the biases. Now we have 10 biases.
Yeah.
So we are calculating loss for like partial derivative for all the 10 biases. So it should be 10.
Yes. So then, what is this thing doing here?
This will be out over here will be from the last layer.
Mhm.
Isn't it? And when it's coming back, this will actually, dB is nothing but dl by dB, so it is trying to find the rate of change of loss with respect to rate of change of the bias.
So
That will be the sum of outputs.
question is, what should be the size of D out?
D out.
Size of D out.
That will be the last layer of
Is number of input and then 10.
Right.
yeah.
So what is this sum is doing?
So it's basically combining that all the input bias
All the
together
input
to
output to
yeah.
one bias.
Yes.
Yeah.
So
So
that is
and
what
then
is this line is
actual
doing.
zero.
Okay, I think our time is up now. Let me see. Let's see. Okay, we time is up. So, Sana, so what is coming next?
So after this, we need to define the activation function
Mm-hmm.
and then the loss function for the fully connected neuron.
Mm-hmm. And learn the code. So, next week we will continue this, and you guys need to learn the basics of the neural net again. So, sometimes learning TensorFlow looks fancy, but you don't know anything using the TensorFlow or anything.
I always go through with this diagram. If I forget 2 neuron, 3, and then convert it to maximum. That's it.
Yeah. So think about the size and is to try to understand what is going on today's seminar, and try to understand line by line. Like the most tricky things are like this. Why should it be transposed or not? Why should we reshape or not? Why we do a sum or not? So some line that why I don't know why this line is here. Those are usually the area you need to study more. So if you understand the meaning of every line, like things like transpose, you are very in a good shape. So try to understand today's course line by line. Okay, guys, thank you, Sanas.
And loss is basically a loss for the whole network as a
Ah,
whole.
yeah.
Yes.
It's not each
Individual loss.
individual node in the output layer, like the whole network loss.
Yes.
Actually, if you do each individual twist, takes a lot of time to go back. So we do matrix multiplication and then sum. And then also we go into the deep batch. If you go deep, then also it will not go into full network.